Okay, now let's look at the first problem, problem number 1 in chapter 9. And it asks about, to get some sample mean and sample standard deviation from the data file. This is the data file, right? And the data file contains this lifetime of 100 light bulbs. And the company wants to know whether it can claim that its light bulb typically lasts more than 1,000 hours or not. Okay, so this is the kind of example. Sometimes, when you introduce new product, or when you, make some certain new services or whatever, you have to make a certain statement. In other words, you have to show how durable your product is, how reliable your service is, and so on and so forth. And, the customers require more objective evidence to support your statement. And in that case, you can use some historical information, historical data, and then using those historical data and historical information, you can prove, you can show that your statement is really true. Okay, and I want you to work on getting the sample mean and sample standard deviations from this data file. And I suppose you can do it. And then let me just write down this sample mean and sample standard deviation. So if you use your star tools and get this sample mean and sample standard deviation, we will get X bar is 991.02. But actually, that's exactly the example we used, right? We used that for battery life for iPhone, but that's exactly the same data file. In this case, now let's assume that it's a lifetime of light bulbs rather than battery lifetime. And then we already know that the standard deviation is 87.17 and n is 100. Now, let's say the first part asks about to identify null hypothesis and also alternative hypothesis. You have to think about the question very carefully. In other words, we already learned that alternative hypothesis is something you want to prove. The role of the original motivation of null hypothesis is I want to reject the null hypothesis in order to support alternative hypothesis. And think about this example. What do you think that what do you think the company wants to show? What do you think the company tries to prove? The company tries to prove that their product, their light bulb, actually lasts more than 1,000 hours. So that should be the alternative hypothesis, right? So the alternative hypothesis should be this. The lifetime of your light bulb, okay? Lifetime is actually longer than 1,000 hours. That's alternative hypothesis. And null hypothesis is no. The lifetime is less than or equal to 1,000 hours. Okay? So that's the null hypothesis. And we want to show, we want to prove whether we can reject this null hypothesis. If we reject this null hypothesis, that implies that we support our statement, we support our argument. So that's a good thing, because I want to demonstrate that the lifetime of my light bulb actually lasts more than 1,000 hours. think about the distribution here. Okay, let's say there is distribution, and we already know that x bar is 991.02. Okay, so this is our x bar. And where do you think we have 1,000? So we have 1,000 probably here. And then we want to calculate some sort of a probability, right? So what we want to do is, let's say probability. What is the probability that lifetime is less than or equal to 1,000? Okay, that's what we want to calculate. That's what we want to calculate. And in this case, we probably need to calculate some t statistic or t multiples, right? So how we can calculate this t multiple? The t multiple is, let's say we have t multiple is 1,000 minus 991.02 divided by 8.717, right? And what is this? That's 1.030171, or just 1.07, 1.03. Okay, then we can calculate this probability using t-dist, right? In other words, we calculate this like a t-dist, and then we use 1.030171. And what is degree of freedom? Degree of freedom is 99. And we are using the cumulative probability. So this should be 0.8473. In other words, this one is going to be 0.8473. What do you think about this result? What do you think about this result? Probability the lifetime is less than or equal to 1,000 is 84%, almost 85%. Do you think it's really strong evidence to support your null hypothesis or your alternative hypothesis? What do you think? 85%. It looks like it's very large probability. In other words, probability lifetime is less than or equal to 1,000 is almost 85%. I would just say this is huge probability, right? Huge probability. And what is this probability? This is actually probability that H0 is true. Okay? H0 is true. So that's the probability that H0 is true, and that probability is almost 0.85, which seems significant. Given that evidence, given that result, do you think you want to reject the null hypothesis? Do you think you will feel comfortable if you say that I reject this null hypothesis? What do you think? Probably not, because the evidence is so strong. In other words, the evidence for H0 is true is so strong, so I cannot reject this hypothesis. And therefore, somehow that implies that my alternative hypothesis cannot be sustained. In other words, I cannot say my statement is true. In other words, I cannot reject the outcome is cannot reject H0. But I want to pay attention to the term 5% significance level and 1% significance level. And I got to tell you that if we consider 5% significance level, that requires us to show them some sort of evidence that says that probability H0 is true at some point. But 0.85 is so huge, and at 5%, at 1%, we cannot reject the null hypothesis. So I will talk about this significance level a little bit further. But in order to understand this significance level, 5% significance level, so first, we have to understand the concept of a p-value. P-value. And well, actually, the p-value of this hypothesis testing is 0.8473. That's the p-value. And in order to determine whether at a certain significance level we can accept or we cannot accept some hypothesis, we needed to compare this p-value and this significance levels. But in this case, the p-value is so huge, we cannot actually reject the null hypothesis. You probably see the basic structure of this whole thing. In other words, basically how we should approach this problem. You probably see at least the overall structure of this problem solving. But I'm sure that you probably have some difficulty in grasping the concept of a p-value and significance level. But don't worry about that. I will get back to those concepts over and over again until everybody understands fairly well. But for the time being, I hope that you follow this whole argument I wrote down on this board. Okay? Now, I want to move to the next question, number 2, and I want to give you some time, maybe 10 minutes, to read this question and identify the null hypothesis and alternative hypothesis. And I want to support your decision whether you can reject or you cannot reject the null hypothesis. Okay? I think that 10 minutes should be enough. So why don't you try to get some answers to these questions? Okay, how did it go? 10 minutes was enough, or you probably need a little more time, but that's okay. Why don't I work on this problem together? And I assume that you already used this data file and to calculate the sample mean and sample standard deviation. And with those, sample mean and sample standard deviation, let's try to, answer these questions. The first part asks is about null hypothesis and alternative hypothesis, right? So in this case, the null hypothesis, or why don't I start with alternative hypothesis? Alternative hypothesis, the amount of detergent is larger than 500 grams. And therefore, the null hypothesis, the opposite of the alternative hypothesis, and therefore it is amount less than or equal to 500. So that's what you need to have. And now we know that the sample size is 100, and then the sample mean is 524.37, and sample standard deviation is 76.22. 2, 2. And now, 100 why don't I draw some picture here as well? So we have this, and then sample mean is here, 524.37. First, I mentioned the p-value, right? And p-value actually, the probability that null hypothesis is correct, null hypothesis is true. That means that this is the p-value is probability amount, let's say less than or equal to 500. Then how we can calculate this one? So this is 500. This is 500. And then we calculate this probability. This probability. How we can calculate this probability? This one requires us to get t statistics, right? So let's say t statistics, which is 500 minus 524.37, and then what is standard deviation? 76.22 divided by square root 100. Okay? All right? Then we know that that's t less than or equal to minus 3.198. Then what function should we use? We need to use t-dist, right? T-dist minus 3.198. And what is degree of freedom? Degree of freedom here, 99. And we are using cumulative probability. So this is going to be what? 0.0009 to 8876. You don't have to go this far. You can just say, 0.0009 should be enough. So look at this one. Look at this one. This implies the probability that null hypothesis is correct is this much. What do you think? Do you think this is big? Do you think this is a big probability or a small probability? I mean that I would just say that this is a really small probability, where I drew the picture in a long way. I mean that I drew it here, so it should be there, so that we have very small probability. Forget about this picture. I made a big mistake. I just want to explain the concept, but this implies that the probability that null hypothesis is correct is so small. Therefore, what do you want to do? What do you think people do when they look at the evidence? The evidence to support null hypothesis is so small, and therefore, what do you think is logical decision? The logical decision is reject the null hypothesis. I want to reject the null hypothesis. Why? Because the evidence is so small. There is not much evidence at all. Okay, now I want to bring this concept of significance level. Okay, sometimes we call the significance level 1%. This is smaller. This is smaller than 1%, right? 1%. So I want to reject this null hypothesis at the significance level 1%. Because the probability that null hypothesis is correct, the p-value is so small, much smaller than 1%. So I want to reject the null hypothesis. Because I reject the null hypothesis even at 1% significance level, I can reject 5% and 10% as well. So sometimes you start with the significance level 10% and ask yourself whether the evidence is larger than 10% or smaller than 10%. if the evidence is smaller than 10%, I want to reject. And then I move to 5% significance level. And if the evidence is smaller than 5% significance level, then I also rejected the null hypothesis, saying that the evidence to support the null hypothesis is not there. And then I move to 1% significance level, and so on and so forth. Okay? So now I hope that you have some, at least a vague idea about what the relationship between p-value and the significance level. Just to remember that the p-value is the level of significance to support the null hypothesis. Okay? So if the p-value is very small, that means that there is not much evidence that can support the null hypothesis. That's what the p-value implies. And you understand, if you understand the fundamental characteristics of a p-value, then you can see how you have to make a decision in terms of a significance levels. Okay? So this is a one-tail problem, and I already said that I drew really bad picture, so it should be here, right? So the probability, this should be 0.00092 or something like that. Okay? So whenever you have to do this hypothesis test, if you draw this distribution curve and then you plot where you have to look at, then I think that your decision will be much easier and much more efficient as well. Okay, we're done on this one-tail hypothesis testing, and now I want to look at this two tails hypothesis testing by looking at the next problem, number three, and chapter 9.